Hi guys, in today's video we're going to be talking about trigonometry. The basics of trigonometry which you'll learn mostly in class 9 or 10. Okay. So the word trigonometry means the measurement of triangles. Trigonometry means measurement of triangles. So we're going to be mainly discussing trigonometry with or we're going to be only discussing about trigonometry with right angle triangles. So as you know, this is the hypotenuse, right? So before we start, you should know some notations which were used in Greek to represent angles in trigonometry. So first one is theta, and the symbol for theta is this. You'll be seeing theta a lot. I think it's the most commonly used. Second one is known as phi, and the symbol for phi is this. Third one is known as alpha, and the symbol for alpha is this. Well, it's not. Let me just draw it a bit better. Actually, usually alpha is just drawn like this for quicker purposes, but the actual symbol which you might even see in your books is sort of like this. But for now, I'm just going to draw alpha like this, which is what you'll see in most places. Then our next one is, oh, 1 second. Yeah, our next one is beta, and beta is drawn like this, and our last one is gamma, drawn like this. Okay, so let's begin. And mind you, you should remember that all of these which I just told you, theta, phi, alpha, beta, gamma, all of them are just, you can say, variables, kind of like A, B, C, D, used to represent different angles. So as you can see, this angle here is represented by theta. So they're just variables used to represent angles. They don't have a specific value defined. So they're not constants. They're just variables. You can call them variables. So let me just change the color. Okay. So we're gonna be talking about trigonometrical ratios. Trigonometrical ratios. So what are trigonometrical ratios? The ratio, suppose you have a right angle triangle. So the ratio between the lengths of of a pair of two sides of a right angle triangle. So any pair, so it could be this side, this side, this side, this side, this side and this side, whatever. So any pair, the ratio between that pair is known as a trigonometrical ratio. It could be any two sides. So there are a total of 6 trigonometrical ratios. I'm going to be telling all of them to you. Alright, say this angle is theta. Okay, and this is perpendicular base and hypotenuse. So our first trigonometrical ratio is known as sine, commonly written as sine. And sine is the ratio between the perpendicular or the opposite side divided by the hypotenuse. Right. So sine is just the ratio between the opposite side and the hypotenuse, or perpendicular and the hypotenuse. You have to remember this. So whenever we have, suppose we have this right angle triangle over here, sine theta, remember sine is perpendicular by hypotenuse, right? Over here, let's say P is A and H is B. Okay, so over here sine would be A by B, right? Because perpendicular by hypotenuse. But if your theta was here, say, yeah, so instead of there your theta was there, then your base, which you see base over here, becomes perpendicular. This becomes your base. So it's important to know where your reference angle is. So in this case, where I just assigned the new theta over here, in this, suppose this side is C, in this sine theta would be equal to C by B, not A by B. These both are not equal, remember. So you always need to see what reference angle you have on where it is. So this suppose you have a right angle triangle, and in this case this is your reference angle. So the side opposite to the reference angle will always be the perpendicular. Side adjacent is base and the longest side is always hypotenuse. Remember that. So always the side opposite to the reference angle theta is the perpendicular. So if theta was here and not here, let me just redraw this. So if theta was there, this theta, then this base would turn into perpendicular and this perpendicular would turn into base. That's how it works. Okay, so I told you the first trigonometrical ratio sine theta, considering yeah, that's better. Considering theta, this sine theta is perpendicular by hypotenuse. So is this side A by this side B, A by B. Alright. Our next trigonometrical ratio is cosine, also known as cos, commonly known as. So in cos is just the ratio between the base and the hypotenuse, or in this case base C by B. So in this case cosine or cos theta is C by B, base by hypotenuse. Alright, it's also, we can also call it adjacent by hypotenuse. That's actually easier to remember. Hypotenuse always remains the same, so this, which is the longest side, so cosine is also adjacent by hypotenuse. Okay, our next trigonometrical ratio is tangent, also known as tan. So tan, considering this theta, tan is the ratio between the perpendicular and the base. So this is the perpendicular base BC and this is the hypotenuse A. So tangent equals to perpendicular by base, which equals to B by C in this case. Tan theta. Remember, reference angle is always important. We can also call tan theta opposite by adjacent. If you remember the formulas this way, opposite by adjacent, adjacent by hypotenuse, opposite by hypotenuse, you don't really need to take regard to the reference angle, it'll just automatically come, because opposite is always perpendicular, and this opposite meaning opposite to the reference angle, by the way. So if this is theta, this is opposite, this is adjacent, and this is base. Okay, see, these are the basic we can say basic trigonometrical ratios. I'll tell you why all, especially remembering these three, are important. You can remember them by this formula, or not formula, mnemonic. SOHCAHTOA. S means sine. Sine is opposite, so O for opposite by hypotenuse. Cosine or cos, this cosine is adjacent by hypotenuse, and tangent or tan is opposite by adjacent. So you have to remember this, very important. Let me just rewrite this once more. Sine equals to opposite by hypotenuse, cosine is equal to adjacent by hypotenuse, and your tangent or tan equals to adjacent opposite by adjacent. These are the basic three trigonometrical ratios. We've got three more, but they're just based on these three. So till now we've done sine, cosine, and tan. Cosine and tangent. Our next trigonometrical ratio is cot, also cotangent. If you can tell by the name, cotangent is the opposite of tangent. So if we remember, tangent was opposite by adjacent, so cotangent will just be the reciprocal adjacent by opposite, or you can also call it base by perpendicular, right? So cotangent or cot is adjacent by opposite or base by perpendicular. And yeah, that's it for cotangent. And next one, secant, is the opposite of cosine, right? Remember our second one. So I'll just make a quick table which will help you, right? So secant is the opposite of cosecant, or of cosine, sorry. So if you remember, cosine was adjacent by hypotenuse, so secant is just hypotenuse by adjacent, or you can say hypotenuse by base. Alright, so now you might be wondering, what's the opposite of sine? Our last trigonometrical ratio, cosecant or cosec. So cosecant is the opposite of sine, or we write this in short for cosec. Short is cosec for cosecant. So if you remember, sine was opposite by hypotenuse, or we can say perpendicular by hypotenuse. So same way, cosecant would just be hypotenuse by opposite, or we can say hypotenuse by perpendicular. Those are our 6 trigonometrical ratios. Let me just write them once. So first one is sine, which is opposite by hypotenuse. It's better to remember this way. You don't need to consider the reference angle then. So sine is opposite by hypotenuse. Cos or cosine is adjacent by hypotenuse. Tangent or tan is let me make this by sign better. Yeah, tangent or tan is opposite by adjacent. Cotangent or cot is adjacent by opposite, so opposite of tangent. Then secant or sec is hypotenuse by opposite, and cosecant is hypotenuse by, oh wait, sorry, this is hypotenuse by adjacent, and this is hypotenuse by opposite. So these are our basic 6 trigonometrical ratios. Alright, so I've got a question for you now. Say you have this triangle. Hold on. Yeah. And this is 90 degrees. This is CA and oh wait, sorry. CA and B. 5. The length of this is 5. Alright. So first we have to find, and this, the length of this is 13. So if you use Pythagoras theorem, you'll get this as 12, right? Because anyways they're Pythagorean triplet. First we have to find sine A. So they've given A, that means this is the angle, right? We have to find the sine of this angle. Sine, if you remember, is opposite by hypotenuse. So opposite is 12 and hypotenuse is 13. So sine A is 12 by 13. Now, what is cos C? That means this angle, cos C. If you remember, cosine is adjacent by hypotenuse, right? Adjacent is 12 and hypotenuse is 13. So this will also be 12 by 13. You see, even though you can see that sine A and cos C are equal, but they're also different because their reference angles are different. That's their only differentiating point. So it can be like that too. You have to remember always. Now, our next question is, okay, in a right angled triangle, so you have a right, hold on, you have a right angle triangle. In this triangle, angle, suppose say this is A, this is B, and this is C. So say this angle is acute, that means it's less than 90, and they've given cot A as 4 by 3. So we have to find sin A. We have to find sin A and uh, cos A. How would we do that? Okay, so what is cot? Cotangent is the opposite of tangent, or we can say, what is tangent? Tangent is just equal to opposite by adjacent. Therefore, cotangent is just adjacent by opposite. That means, taking this as the reference angle, adjacent means this side. So this is 4, right? And this is 3. Or let's call them 4x and 3x. We can't directly assign. So this is 4x and this is 3x. Alright. So using Pythagoras theorem, we can figure out that this is 5x because they're a triplet. So what is sin A? Sin A is equal to opposite by hypotenuse, right? So A, this is the angle. So opposite of this is 3x by hypotenuse 5x. X cancel, all you have is 3 over 5. That's sin A. And cos A is adjacent by hypotenuse, which is equal to cos A. So this is the angle again. So adjacent is 4x by hypotenuse 5x. X cancel, all you have is 4 over 5. That's the answer for this question. Alright. One last question. Alright. So if you have this figure, let me just draw it. Okay, this is a right angle triangle. And this is also a right angle triangle. Say this angle is beta. Let me draw that. Yeah. Say this angle is beta and this angle is alpha. Okay. So we need to for in this cos alpha, they've given us the value as 5 over 13, and cos beta, they've given us the value as 3 over 5. So from that, what can we tell? Over here, I'll also tell they've given this as 8 and they've given this side as 12. Let me just label these. Yeah. So they've given this side as 12, this side, and this side as 8. So now what do we have to find? Let me just reduce the size for this. So what do we have to find? So find the length of BD. So find the length of BD. How are we going to do that? Okay. So they've given us cos alpha as 5 over 13. So cos is equal to adjacent by hypotenuse, right? That means BC would be equal to 5x and hypotenuse, which is this side, would be equal to 13x, right? Because adjacent by hypotenuse. We have 5 over 13. Cos alpha is 5 over 13. So we've got this side, and this side. The x cancels out, so we don't need them anyways. So we have to find the length of B and D. So we already have BC. I'm just going to write here BD equal to BC plus CD. Right? BC plus CD. is BD. And we already have BC, which is 5. So all we have to find is CD. So they've also given us cos beta is equal to, what have they given us? Cos beta is equal to 3 over 5. So if you look in the figure, what is cos? Adjacent by hypotenuse, am I right? That means this CD is just 5x, sorry, 3x, and this, right? Therefore, or no, wait, yeah. So therefore, this side x cancel, this side becomes 3, CD becomes 3. Alright, so we had BC as 5 and CD as 3. So BC plus CD equals to BC plus CD equals to BD, as I showed before, right? So 5 plus 3 equals to BD. Therefore, BD equals to 8. That's the final answer. And that's it for the introduction into trigonometry.